Hello students. Today let us see about some points. Out of this, the one is spontaneous process. Spontaneous process is that process which have a natural tendency to occur on its own and do not require any external influence for their occurrence. Okay, this is the spontaneous process. The spontaneous process is the process which have a natural tendency to proceed in one direction and do not require any external influence for the occurrence. This is the spontaneous process. Actually, it is a irreversible process, is it? So it cannot be reversed, is it? So these are the features or the properties of the spontaneous process. The one is it proceeds in one direction, it proceeds on its own, the first, and then the second one is it is unidirectional, it proceeds in one direction. The next is does not require any external influence to occur. It proceeds in one direction and can't be reversed until a stimulant is present. That means if we do not stimulate the process to be reversed, it continues till the equilibrium is attained. So it is a irreversible process. Okay, it continues in one direction, that leads to the equilibrium state. And two example here we can consider, which are the natural example: water flowing from uphill to downhill, or you can take the example of the waterfall, okay, which continues to fall on the ground from the top of the hill. The second example we have taken here, that is flow of heat from the hot end of a metal rod to cool end. That means if a metal rod is heated at one end, ultimately the heat flows from hot end to cool end of the metal rod. So these are the example. Basically spontaneous process that is proceeds on its own in one direction and it does not require any external influence for its occurrence. So it is a reversible process. We have seen previously the reversible process. What is a reversible process? Reversible process is the one where there is the driving force is infinitesimally greater than the opposing force. That means the reversible process can be reversed at any stage or any moment, is it? But irreversible process can't be reversed, is it? So this is all about the spontaneous process. Okay, see the example of spontaneous process. Here water is flowing from uphill to downhill, is it? Water flowing from uphill to downhill, and it is a spontaneous process. Another example is this: when a metal rod is heated at one end, heat transferred to the cool end. So this is the natural unidirectional process, which is a spontaneous process. Say we have seen the spontaneous process, is it? The spontaneous process is the process which proceeds on its own and it does not require any external influence to its occurrence. Now how energy is related with the spontaneity of a system or process? Now actually, if we consider the reactions, there are exothermic reactions and endothermic reactions. Exothermic reactions are those in which heat is given out. That means after giving heat, the energy of the system will be lowered. Endothermic are those processes which consume energy in the form of heat. That means heat is added to the system. Now how spontaneity and energy are related? Actually, in case of a spontaneous process is the process which proceeds in one direction in which the energy of the system is lowered. Is it? Actually, spontaneous process are irreversible process. There is the tremendous loss of energy takes place. Is it? Now, so that's why it is said that spontaneous process proceeds in one direction and there is the loss of energy takes place. That's why energy of the system can be lowered or it is lowered. Now, for example, if we consider the chemical reaction, the reaction between base sodium hydroxide and HCl, see here the heat of the reaction, it is found to be minus 57 kilojoules per mole. That means the energy is decreased and it is a exothermic reaction and it is a spontaneous process. It is a spontaneous process. Okay, that means the neutralization once started, it sticks or it occurs on its own. That's why it is a spontaneous process and it is an exothermic reaction where heat is given out. The energy of the system is lowered. But if we consider the two reactions or two processes, that is melting of ice. Melting of ice, it takes place by the consumption of heat energy. So when ice melts, it converts to liquid and it is the endothermic reaction and it is a spontaneous process still. Another example, if we consider dissolution of sodium chloride in water, see, it is also a spontaneous process and it is endothermic process because see, delta H, the enthalpy change of the reaction is plus 3.9 kilojoules per mole. So it is a positive enthalpy change. So it is an endothermic reaction and it is spontaneous process. That means exothermicity or endothermicity is not the criteria to be a process. It is a spontaneous, is it? So to decide or to study the spontaneity or spontaneous process, we have to consider, we have to just go for another factor, that is entropy. Is it? See, it is denoted by the capital S, entropy. Now actually before going to all this, I will just state what is the entropy. Say, entropy is the measure of molecular disorderness or randomness in the system. So entropy is the measure of molecular disorderness or randomness in the system or substance, simply. Is it? So the disorder or randomness is measured by a thermodynamic property which is called as entropy. Simply, this is the statement of entropy. Now let us study all about entropy. Now see here, ice. It is a crystalline arrangement of the water molecules. So molecules are arranged orderly in the crystal of the ice. Is it? In ice, molecules are arranged orderly, and in case of water, the molecules are in disordered state. Further, if we just go for the water vapors, gaseous state of the water, then there is the highly disorderness of the molecule, water molecules is found. That means the water molecules are in highly disordered state. Okay. Here orderly arranged, here disordered state and highly disordered state. Here, see here, in case of the ice, the molecules are, we can find in the arrangement of the water molecules is in order state. Further, if ice melts to form water, the orderly arrangement of the molecules of the water is collapsed and there is found the disordered state of the water molecules, and further water is converted to its water vapors, then the water molecules are found in a highly disordered state. That means the disorderness or randomness of the molecules goes on increasing from solid to liquid, liquid to gaseous state. Is it? That means the randomness or disorderness increases from solid to gaseous state. That means the change in enthalpy. Enthalpy is shown by capital S and the change in enthalpy is shown by delta S is greater than 0. It is positive. Here the enthalpy is increases while going from solid state to liquid state of water. Again, while going from water, liquid state to vapor state of water, the enthalpy again increases. Okay, that means the delta S is always positive while going from solid to liquid, liquid to gaseous state. That is, delta S is always greater. We have taken here two examples. Here, the crystalline solid iodine is dissolved in water, then formation of water, that is iodine solution takes place. That means here the orderly arrangement of the iodine particles is that means disorderness increases in its liquid state. That's why the entropy change in positive. Again, here hydrogen gas is converted to hydrogen atoms in the gaseous state. Again, the number of molecules here increased. Is it? One molecule was there, one particle of the hydrogen gas was there in the reactant side, and here in the product side there are two particles. The number of molecules are increased. That's why the molecular disorderness has been increased. So delta S is positive. Is it? Here in these two cases, the entropy changes in positive. That means entropy increases. The entropy increases. If we see in the next example, formation of water in liquid state, that is gaseous hydrogen reacts with gaseous oxygen to form liquid water molecules. That means here gaseous state is converted to liquid state, means molecular disorderness is decreased while going from gaseous to liquid state. So that's why the change in enthalpy, the entropy decreases in this reaction gaseous to liquid. The entropy decreases. Is it? Gaseous to liquid state, the entropy decreases, and that is found to be delta S is equals to minus 327 joules per Kelvin. Okay, so still see here the entropy is been decreased. In these two cases the entropy is decreased. So what is the entropy? It is the measure of molecular disorderness or randomness. As the molecular disorderness increases, the entropy also increases. Then that because of the increase in entropy, the change in entropy will be positive or it is greater than 0. This is all about the entropy, spontaneous process, and energy and spontaneity, and the entropy of the system. See students, the next point, the quantitative definition of entropy. We have seen the definition of simply entropy, that is molecular disorderness or randomness is measured by the thermodynamical property which is the entropy. Now quantitative definition of entropy, that means in terms of a simple formula, actually yes, it is represented by the capital S, entropy. It is the measure of molecular disorderness. Now entropy change, now see there is a change in entropy while going from changing the state of a particular system. There is a change in entropy takes place. That's why we are just looking for the change in entropy delta S of a system. Now change in entropy of a system delta S is equal to amount of heat transferred to it in a reversible manner divided by the temperature in Kelvin. So entropy change delta S of a system is equal to the amount of heat that is transferred to the system in reversible manner divided by the temperature in Kelvin. Here the amount of heat supplied to the system or transferred to the system is in joules, and then the temperature in Kelvin. That's why the unit of change in entropy delta S is joules per Kelvin. Okay. Now the entropy S or change in entropy delta S is a state function, because the amount of heat as well as that is the temperature and Q are the state functions. So delta S, now see here, as we transfer the heat to the system or we supply the heat to the system, then the kinetic energy of the molecules or particles of the system increases, and that's why the molecular disorderness or randomness increases and the entropy also increases. That's why here the change in entropy is directly proportional to the Q, the amount of heat. Now see, as from this we just concluded that the amount of heat by the transfer of amount of heat or that is the heat being added to the system, the molecular disorderness increases and the entropy increases. But the effectiveness of the addition of heat depends upon the temperature of the system. Whether if the temperature is higher while addition of the heat, then the entropy, increase in entropy or the increase in molecular disorderness is different than when the amount of heat is added to the system at lower temperature. So this is the fact. Effectiveness of the addition of amount of heat depends upon the temperature of the system. So this delta S is equals to Q upon T, the amount of heat transferred to the system in the reversible manner divided by the temperature. So this is the quantitative statement or the definition or the meaning of the change in entropy. Okay. Now second law of thermodynamics. Second law of thermodynamics is just depends upon the entropy. Now see, second law of thermodynamics states that total entropy of the system and its surrounding increases in a spontaneous process. So that's why, therefore we can write delta S total is equals to delta S system plus delta S surrounding greater than 0. So being in the spontaneous process, the entropy of the system and its surrounding increases, this sum is the change, total enthalpy change is always greater than 0. Now considering this equation for the formation of the liquid water, that is gaseous hydrogen reacts with the gaseous oxygen to form liquid water molecules. That means gaseous state to liquid state, conversion of the gaseous state to liquid state, highly disordered state to less disordered state. That means in this case obviously the entropy, the molecular disorderness decreased or randomness of the molecule decreases. That's why entropy decreases obviously. That's why the change in entropy of this reaction delta S is equals to minus 327 joules per Kelvin, and the change in enthalpy for this equation or reaction is minus 572 kilojoules at 298 Kelvin. Okay. Now see here, from this relation we can find out the total change in entropy, is it? So to find out that, we are already known about this entropy change of the system, but we have to find out this change in entropy for the surrounding. So we can use this relation. The change in entropy for the surrounding delta S of surrounding is equals to Q upon T. Here Q is delta H because the enthalpy change for this reaction is negative, and at the same way the delta H for the surrounding is the same amount, but it is change in sign, opposite in sign, that is positive, plus 5, because this amount of the enthalpy is released, minus 572, that is added to the surrounding. That's why minus 572 is for the system, and that will be plus 572 for the surrounding. That's why divided by T. At what temperature? 298 Kelvin. But it is in kilojoules, that we have to take in joules. Is it? As per the change in entropy, delta S, quantitative definition of entropy, that is Q in joules. 572 into 10 to the power of 3 joules divided by 298 Kelvin at this temperature. So we got 1919 joules per Kelvin is the change in entropy for the surrounding. So keeping this value in this relation, so delta S total is equal to 3, that is delta S for system is 327 plus delta S for the surrounding we calculated as 1919 is equals to plus 1592 joules per Kelvin, which is always greater than 0. So from this value we can conclude that the reaction is spontaneous. The reaction is, the delta S total is positive, greater than 0 means it is a spontaneous reaction. So from the delta S values we can just give the 3 relations. Okay, if delta S total is greater than 0, if it is positive and greater than 0, then the process is said to be spontaneous perfectly, as we have seen here. And if delta S total is less than 0, it is negative, then process is non-spontaneous. Okay, and the delta S total is if 0, then the process is at equilibrium. Okay, if suppose delta S total is greater than 0, okay, that is spontaneous process. If it is less than 0, non-spontaneous. If it is equals to 0, process is at equilibrium. Is it? So this is all about the second law of thermodynamics and the entropy of the system. So what is the second law? Second law states that the total entropy of the system and its surrounding increases in a spontaneous process. Okay. So the rest of the points we will just discuss in the next session. Goodbye and have a nice day.